Welcome back to DentChem. We're going to get some extra practice here with some hybridization. So you've watched the previous video and now you've tried this on your own and we're going to work through it together. We'll start from right to left here. Remember, I'm just looking for electron groups. That's all I'm really doing. And I'm converting that into hybridization. Where are those electron groups located in an orbital? Start from right to left. I have a carbon here. Making one carbon bond, 3 hydrogen bonds, 4 electron groups total. That is going to be sp3. Similarly, I have a carbon here making 2 carbon bonds, 2 hydrogen bonds not drawn in explicitly, 4 groups total. Look at my chart, sp3. I have a heteroatom here of a nitrogen. Not drawn in here is a lone pair, right? Nitrogen likes to have 5 valence electrons. You learned that in general chemistry. So not drawn in, I go ahead, I draw that in myself, and now I can clearly see that I have 1, 2, 3, 4 electron groups. Our nitrogen as well is going to be sp3. And now I'll get onto my benzene ring. Should be a lot of purple here. Our benzene rings are flat, and each atom should be trigonal planar, should be sp2. We can see that here. For example, this single bond, electron group. This double bond counts as 1 electron group. So now I have 2 total, and then this single bond going down to another carbon counts as electron group. 3 electron groups, sp2. And that, you can use that reasoning for all of our benzene atoms here. All going to be sp2. And since they're all individually trigonal planar and flat, that means benzene rings are flat as well. When we learn about aromaticity, this is going to be very important. Let's actually extend this down. Our aromatic system goes down here as well. This carbon here, 1 electron group this way, our double bond. 1 electron group going up as our single bond. And then not drawn in here is a hydrogen. 3 electron groups, sp2. And the same can be said for this terminal carbon over here. Our methyl group here is going to be sp3, 1 carbon bond plus 3 hydrogen bonds, 4 bonds total, sp3 for that group there. 2 carbon bonds, 2 hydrogen bonds, 4 electron groups total, sp3. You remember from the previous video, hopefully, our carbocations, okay, electron deficient, they're going to only have 3 electron groups, making them sp2. Secondary carbon here, sp3. And then we have a carb anion, so electron rich. There's a lone pair not explicitly drawn here, so I'm going to do that myself. Carbon likes to have 4 valence electrons. Our carb anion tells us that we have 5. Okay? Carbocation tells us we only have 3. Carb anion tells us that we have 5 valence electrons. So I have 2 valence electrons in the lone pair. I have 1 in the bond, meaning I need 2 more. What I don't have drawn in here are some hydrogens. And there's my carb anion. Now I'll look just the same at electron groups. The single bond to carbon, that's 1. The lone pair, that's another electron group, I'm up to 2. Our hydrogen bonds are going to count as electron groups as well. They're single bonds, so 1 hydrogen, 2 hydrogens. I have 4 electron groups. A carb anion, even though it has an extra electron, you can think of it that way, is still going to be sp3. Lots of sp3, lots of sp2. That should stay consistent in organic compounds and throughout the semester. You're only really going to see sp usually with alkynes. And this sp2 stuff especially is going to come up in aromaticity and will be more important then. Hopefully that helped. Thank you for supporting the channel. Like this video, please subscribe. You'll get more help with DentChem for free. Thank you.